Hi everyone, my name is Trisha Kumar, and today I'm starting a new playlist called Data Science Projects. And I have been spending some time working on a couple of projects, and I decided to make YouTube videos explaining how these projects work in detail. The code will be posted on my GitHub account, and I will post the YouTube video along with GitHub on LinkedIn. So now the first project that I'm starting off with is the selling price of used cars. So let's get started. So this is I have done this project on Jupyter Notebook, and output.csv is the CSV file, the data set which I'm using to analyze the selling price. So obviously first we import NumPy because it's impossible to do a data science project without NumPy, right? So NumPy in general is used for working with arrays. Then I've also imported pandas, matplotlib, seaborn, and scipy. Matplotlib is pandas is used for manipulating the data sets, allows us to represent the data in different ways. Matplotlib is used to give an animated visualization for the data. Seaborn is used for statistical graphics in Python, and SciPy is used to solve complex mathematical problems. Now, next we are going to import the CSV file by typing the path of the CSV file and reading the CSV. Next, the head of the CSV, which shows all the details. This is actually raw data with a lot of missing values and stuff. And you notice that there are no column names also for this, so it's like really raw data. Now we're going to give, in the next step, I'm going to give headings for each column. So the first column is symbolizing the normalized losses, then make, fuel type, aspiration, and so on. Next, I am making data.df, and I am also going to use isNA and isNull to check about any missing values. The difference between isNA and isNull is that isNA is just used to detect the missing values and gives out like a Boolean expression, and isNull checks specifically for array-based objects. Next, we're going to convert MPG to liter per kilometer, 100 kilometers. MPG is miles per gallon, and liter per 100 kilometer is like obvious. Every liter that is spent for every 100 kilometer, because that's an easier way to measure. We are also going to find out all the data types available in this data set. So you notice there's int, and there are objects, and then there's float. Next, we find out all the unique values available using data.price.unique. We notice that there are some question marks also in the middle, and we want to remove that because they are it's unclean data. So now we remove this question marks, and then again check, and now notice that the data types is not filled with the question marks. Next, we will be normalizing the values by using simple feature scaling method. So for using simple feature scaling method, we need to do binning. So like binning is the process of continuous variables being divided into discrete intervals or bins. So we divide it based on length, width, and height, and we keep it as low priced, medium priced, and high priced bins. So this is the analyzed version of the bins, and this is the graph version. As you notice, the low price binning set is more, and medium and high is pretty less. Now we separate the numerical values, and all the NaN values are skipped, and now I've described the data set how it looks right now after cleaning everything. Now we're going to use Seaborn and Matplotlib to build a scatter plot where the x-axis is the engine size and the y-axis is the price size. So this is a scatter plot of engine size versus price size. Next, we're going to group the data according to wheel, body style, and the price. So we make a test data set and group the data. So this is how drive wheels, body style, and price works. Now we're going to use the pivot method and plot a heat map according to the data obtained by pivot method. Pivot method is used to reshape the data by transforming rows into columns. So we've transformed all these rows into different columns. Now this is the heat map for visualizing the above data. Next, we're going to obtain the final result to show it in the form of this graph. As you notice, the slope is increasing, so it is a positive relationship between engine size and price. So also you can notice that all the dots are scattered right near the line, so it is a really strong correlation. It's a very strong correlation and is dependent on each other. So that's all for this video. I hope you guys understood this. Please like, share, and subscribe. Thank you.